Okay, hello everyone, and welcome back to my YouTube channel. And today I have the pleasure of having a video about one protection device. Okay, as you must be aware, I have been preparing a set of videos related to protection systems. And right now, we are in the stage that we want to create and establish a very well equipped protection lab. Okay, and today I have a beautiful job. Today I will be presenting to you a walk around of this beautiful SEL 751. The SEL 751 is manufactured by Schweitzer Engineering Laboratories. And this 751 is basically a feeder protection relay. Okay, I am really proud to having this equipment at the lab. I have probably one of the best specification of this relay. And the plan of this video is to show you a walk around presenting some of the basic functionalities and also showing you the device, the physical device, showing you the front panel and the back panel and the sides. Okay. But before we start with the physical and real device explanation, I would like to tell you a bit about this SEL 751 feeder protection relay. Okay, um, this relay is basically a feeder protection. That means that is intended for the use at distribution system, and this device is able to work with radial configuration or loop distribution configuration. Okay, and the device is equipped with a very comprehensive protection capabilities, including, of course, the classical overcurrent, but going beyond that with differential overcurrent, auto reclosing, under voltage, under frequency, cable line thermal, and so on. Okay. This device is probably one of the quite new relays in the portfolio of Schweitzer Engineering Laboratories, and this device has a very interesting, a very important feature. Okay, as you can see here at the presentation, there are two photos of the devices. Okay. Here on the right hand side, you can see the classical presentation, but on the right hand side, you can see the most modern using the touch screen. And I would like to focus a bit of the time here with this sensor over there, because this 751 is equipped with what we call the arc flash detection. The idea is that this is a sensor that is installed in order to detect in a very fast fashion, and we are talking about around 2 milliseconds, arc flash detection. That means that it's possible to detect when the arc is happening at the equipment, and in this case, the relay offers a combination between light and high speed on the overcurrent protection in order to solve issues related with our flash events. Okay, we are talking about this is a very important feature and very important feature for safety at distribution system. Okay, but also this device is equipped with the modern technology that is able to have a very sensitive protection for earth fall, including high impedance fall. Okay, and we are talking about that this device has the possibility of detecting in a very precise fashion neutral currents of 200 milliamps. Okay. Um, Here you can see a set of the very different protection functionalities inside this device. As you can see, this is a very complete relay, including protections starting from under voltage, including the inverse characteristic, by going across the over voltage and going deeper into phasor shift, directional power, loss of potential, and of course the classical features like the classical time over current for phase ground and negative sequence, and the classical instantaneous current for phase ground and negative sequence. Okay, this is a very well equipped device. Okay. um, Several features are related with this device. One of my favorite features in this device is the front panel. As usual, the blue color coming from Schweitzer, and but in this device they has include a touch screen, a touch screen that allow you to control in a very simple and easy way the settings and also communications in this relay. Okay. In a minute, I will go for the real device. At the moment that I am recording this video, there is no power supply. However, I would like to tell you that the next video, I will switch on the device and show you how to go through the folders or the menus and submenus. Okay. At here, as you can see, this is the same model that, well, similar model that the one that I will show you in a minute. This is the version with 8 buttons at the front, including 2 more for the home and to reset the target. But in this case, we have the 4 basic buttons that you have in the classical relay, including the lock and close and trip. But also we have on the left hand side here 4 more buttons that they can be configured. Okay, here at the left hand side you will have several LED. Those LED they are colored. That means that we are talking about at least 3 different colors per light. And as you can see over here, you can see there is one in order to show you that the device is properly working and the self-tests are okay. Then we have here a light that we don't want to see so much, that is the trip, because we will have a fault. And here there are some indicators about possible conditions like the instantaneous overcurrent trip, phase overcurrent trip, ground time over current trip, neutral time and negative sequence time over current trip. Then we have over and under frequency and the very important breaking failure. Okay. It's quite typical that SEL relays, they have at the front port for communication. That is the called port F, and typically is RS232 connectors. Okay. In this case, the physical device that we have at the lab is not equipped with the front connector, because we are using Ethernet connection at the back for the connectivity. Okay, because we are interested in doing research on IEEE 68150. Okay. Well, if you allow me, I will switch the camera and I will go to the physical relay. Okay. Now we have you have in front of you the physical relay, and in this case you have in front of you the real SEL 751 feeder protection relay. Okay, one of the lovely features that you can see over here is that we have a touch screen. Okay, many of you probably will complain because we are using fancy technology at industrial level, but to be honest, that is one of the features that I like. Okay, this is basically a color 5-inch touch screen display, and I fall in love with this functionality. Okay, it's not so high resolution, it's 800 by 480, but it's good enough to recognize all the icons and showing you the information. And also the intensity and contrast, the bright and the contrast in this screen is quite good. Okay, as you can see, again, this is the plastic. This is a very blue color over here. We have the A buttons that I was talking about. Four of them, they are classically included in all the relay, and we have four out more, okay? Those are the three colors LED that we were talking about. In this case, four different indications, starting from a status and defining that the device is properly working, going through a different type of faults, okay? What I will do now is I will turn around this device. I will show you this side. Um, as you can see over here on the left hand side, you have the classical label with all the details about the specification of this relay. In this case, for this very specific relay at the lab, we are using a supply, a DC supply between 24 and 48 volts. Okay, and this device has a very low power consumption. We are here in the area of 25 watts. Okay, of course, this device is equipped with uh, the classical inputs for voltage and currents, and we will discuss that in a minute. Okay. Now, what I am doing is rotating the device on the right hand side. The right hand side is extremely important for me, okay, because Schweitzer engineering laboratories, they have this feature that is having a label with the different terminals and labels and the use of them in your relay, okay. um, at the very beginning, what you can identify here is that there are several sections. There are letters for there A, B, C, D, E, Z. Okay. If you are a rookie on physical protection relays, probably you don't recognize, but the last one over here with the letter Z, Zulu, that is used for the inputs of this relay. Over here, as you can see, there is inscription for two terminals, Zulu 01, Zulu 02 for the current at A. Of course, here we are using A, B, C as a letter for representing the three-phase system, and the classical letter N for the neutral point, okay? And here you can see that Zulu 09 through Zulu 12, they are designed and they are defined for the voltages A, B, C, and neutral, okay? Um, of course, here there are several other cards. In this specifically relay, the bay D is empty at the moment because that is dedicated for a card label. Okay. Um, Over here, there is a section for inputs, and also there are a card that is related with the power supply. Okay, as you can see over here, the connector with the terminals between 0 to 6, they represent the connectors, the terminals used for power supply and interactions. Okay, specifically the 01 and 02 of the bay A, they are used for the positive and negative voltage that we apply for supply. Okay, what I will do now is I will turn around the device over here. Okay, right now you are able to see that we have here the bay A, then we have the bay B, then we have C, D is empty, then we have here the area for the bay E, and finally for Zulu or set, okay? If you give me a minute, what I will do is I will show you a cross section inside this device in order that you understand a bit more about the construction of this relay, okay? As I explained before, this relay is very well equipped with several sensors, several cards, okay? I remember that I told you about the slot A that is basically dedicated for the power supply and some of the inputs, outputs of this relay, okay? As you can see here, this is the physical real relay. And as you can see over here, this is the terminal. This is one of the terminals. This is the second terminal for the slot A. Slot B is basically dedicated for processor and communication. And as you can see here, for instance, one of the very distinctive connectors that you can find, terminals that you can find here, is the RG45 used for Ethernet connection, okay? In a minute, I will give you more details, but then we have the expansion card C that you can find here. Then in the case of the relay that we have at the lab is an empty space, but this empty space can be completed by including one more card, okay? As you can see in white color here at the very end, you have the connectors, the terminal for connecting the expansion card if we have some expansion card here. Then we have some communication expansion, and that is the card letter E. Okay, here the letter E represents one expansion card related with some communication. And finally here, the very important Zulu load slot or slot set that is basically for terminals related with the inputs of voltage and currents. Okay. Well, now what I will do is I will go back to the physical relay and I will show you some features that they are quite interesting and quite useful for me. Okay, now we are here at the physical relay. And you can see the back panel of this SEL 751, okay? As I said before, this device is quite robust and quite solid, okay, in construction. As you can see, there is aluminum to top quality aluminum. And as I said before, the first slot over here, the slot A, alpha, is dedicated for the connection for the power supply of this device. Okay, and specifically, if we look over here in this section over here, that is the point for connecting the power supply. And as you can see in yellow color, there is a clear label saying that this device is for DC power supply between 48 or 24 volts, okay? If you remember, alpha 01, alpha 02, they are dedicated for the positive and negative voltage, okay? And here, of course, there is a bolt for the grounding connector, that is the ground for the metallic components, that is for safety. One feature that I extremely love of this device is those connectors, okay? And when you are physically connecting the IED, the relay in your rack, sometimes you need to connect the cables in a very difficult position. Those kind of connectors, those are screw connectors. As you can see over here, there are some screw. And over here is the space where you put your cable over here, and then you can make the connection outside your rack or in a very easy or comfortable position.
And then what you need to do is go back here to the relay, push in, and then you use two screws to the side to keep the block together, okay? That is one of the lovely features that I like from this device, okay? Well, as I said before, this device have some connectivity. The Ethernet connector over here, the port 1, the Ethernet connector is especially important for me because that will enable for me the communication, and that will enable later trying some new features related with IEEE 601A5, okay? Here you can see also optical fiber optic connector for serial port. And if you look over here, we have a block, and that block is basically for arc flash detection, okay? Finally, I will close my explanation about this relay, going back here, going down here. As you can see here at the very bottom, you will find the Zulu card or the slot Zulu or set. As you can see over here, there are inscriptions, and those inscriptions are related with the voltage and current inputs, okay? As you must be aware, our lab is based in Europe, and as a consequence, this device is designed for, is working for 50 hertz, okay? It's something that you can configure using the software. In this case, we are in Europe, and we are using 50 hertz. But regarding current transformer, the current transformer inputs are located here, and we are using 1 amp phase for the AC currents input. Okay. Regarding the voltage, the secondary of the voltage transformer, we are assuming that we will use here almost until 300 volts AC, okay? However, those terminals are designed for much more. They are tested for 600 volts AC over 10 seconds, okay? This is the back of this device. I have complete a workaround on this beautiful device. Now it's time to close this video. I hope you enjoy working around this feeder protection relay, this amazing and very useful device from Schweitzer Engineering Laboratories. It's a very interesting and very beautiful device, okay? In the next video, I will put some electricity in this device. I will just include the power supply, the 48 volts DC, in order to switch on the device and showing you some features related with the touch screen, okay? As I said before, that is one of the features that I love, and I am sure my students will love having this feature in the relay because it's extremely simple, very user-friendly human-machine interface, and that will allow the student easily move through. Okay? However, probably this is not the real situation in every single substation. We're still having some electromechanical devices that we need to test, but that will be covered in another video. For the moment, this is all for this workaround on this feeder protection relay from Schweitzer Engineering Laboratories, the SEL 751. Thank you very much for watching the video. If you want, you can subscribe, and see you at the next video. Thank you.